Well, welcome back for part 2 of the energy unit notes. And we're going to tie some things from the first part. Remember this list here that you have on page 4 of the different forms that energy can take. And this is just one way to describe these forms. There's actually different ways. For example, we can take mechanical energy, and sometimes you'll see that listed separately as kinetic or potential, or maybe different forms of potential. Sometimes you'll see on here things like solar energy or wind energy, when really all of those are some form that you see on here. So this is just my list, and our textbook kind of uses that, so I'll stick with that. So now we're going to be talking about energy conversions. Sometimes you'll hear this called transformations. And it's an important idea to know because energy does not just stay in one form all the time. In fact, so many important processes in life are processes where energy changes from one form to another. And that's just another way to describe conversion or transformation, is a change. So we can just describe it this way. Changing energy from one form to another. So we could almost think of those words as synonyms, like change and conversion and transformation. So when you hear that described, just you can replace that with whatever word you like. So here's an example here that's actually in section 15.2 in the textbook. They have a little description of it, and they have a diagram that goes along with it that's kind of nice to look at. And what it does is it has you think through what are all of the energy conversions or transformations or changes that happen just in the simple act of striking a match, lighting a match. So, what does it take to get that started? You have to do something. You're holding the match, and the striker or whatever it is you're going to light against, usually a little matchbook or something, and in order for anything to happen, you have to start moving. And that requires that we use some of your stored chemical energy in your body. I mean, that's what the cells in your body, a lot of their function is to store the energy so that you have it to do the important things you need to do, such as walking or running or thinking, breathing, etc. But one of those things would be the motion of your hand. So this form, we would say, is the chemical energy, and I'll describe this a little further. Chemical energy stored in you. All right, and what does that chemical energy allow you to do? It allows you to move the match against the striker. So motion energy is the mechanical form. Remember, that would actually be classified as kinetic energy, and kinetic energy is one of the two forms of mechanical energy. Okay, and then what happens next? Well, once you start those two surfaces moving against each other, you create a little bit of heat just from the friction. And what is our form of energy that we use to describe heat? That's called thermal energy. All right, what does that thermal energy cause? Now, this is a little chemistry that you may or may not know, but as soon as you have a little bit of heat, then the chemicals that are in the head of the match, the flammable part, that reaction causes a release of that stored chemical energy. So this is also chemical energy stored in the match head. And you don't need to know what that chemical is. It's actually some derivative with sulfur in it, I know. And so, okay, so then we get that chemical to start reacting. That energy is given off, and we finally get to what we're actually trying to do with the match. So there's two forms, actually. So you see me kind of split off here. That chemical energy, and this often happens with chemical energy, is converted into two different forms. One is, of course, the heat, and so you can use that to maybe warm something up. I don't know that I'd warm up too much with a match, but that, of course, is called thermal energy. And it used to be, back in the days before maybe phones with lights and flashlights were as common, you could actually light a match in the dark just to give yourself a little bit of light to see by. Well, what do we call the form of energy associated with light? That's electromagnetic. Fancy term for what you and I call light. And so there we go. We got all of these different forms that just one leads to the other and leads to the other. So just think about this. I'm going to connect it with the next statement here. We are not creating some new energy when we light a match. You might think, oh, we suddenly have some heat that we didn't have before. Well, it's true we didn't have the thermal energy, but all that energy came from somewhere. I mean, even this stored chemical energy in you came from the food that you ate, maybe earlier that day or the day before. And that food got its energy because it was either, a plant or an animal that you consumed, and that got its energy, maybe it was an animal, by eating other food. Or if it was a plant, it had to absorb energy from the sun in order to undergo photosynthesis to store that energy. So ultimately, we can trace everything back. And so we are not creating energy. We are simply changing it from one form to the other. And this idea, and I'm calling this probably the most important and fundamental idea in all of science, and I'm not exaggerating there. It's known as the conservation of energy. And it goes by kind of different phrases, but I like to think of it this way. During energy conversions, no new energy is created nor is any lost. Or you could say destroyed. Like, we don't get rid of energy. We might get rid of the chemical, perhaps, in the match head. You look and say, oh, it's gone. But the energy associated with that chemical has been turned into something else. So you'd say it simply changes form. Okay? So conservation of energy. All the energy that we have in the universe is already here. We're not going to get any more. If we want to use it for something, we're going to have to convert that, whatever form it's in, into something else. Okay? So we'll explore that a little bit more in the activities and the labs that I have connected with this part. But this gives you a good start, and so we'll go from here. All right, that's it for now. Thanks for watching.